The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to today's Tech Talk on all about six-way valves. My name is Liz Fisher, and I will be the moderator for today's session. As you know, the lines are going to be muted throughout this presentation so we can minimize the feedback. You should also know the attendee control panel appeared on the right side of your desktop. On the left side of this control panel is a small tab with an arrow icon that allows you to minimize and maximize it.
Loser.
Are you still there, Nick? We'll be gathering questions throughout the Tech Talk, and we'll leave a little time at the end for Q&A. If your question is related to a particular slide, please include that number of the slide in your question and use the control panel labeled questions to send them.
Right here.
So, Nick?
Yep.
You've got your screen up now?
It's still not giving me an option to share my screen here.
It says we're viewing your screen.
How about now?
Oh, it's a webcam.
So Nick is an engineering manager with HCI. He has a Bachelor of Science in Mechanical Engineering. He has 10 years of industry experience with 5 years focused on hydronic balancing and hydronic system design.
Hey everybody, this is like I said, Nick Miller. We're having a little technical difficulties getting the presentation up and running, but once we do, we'll be off to the races. So bear with us here. There we go.
There we go.
All right, I think we're seeing my screen now.
Yep.
All right, very good. Well, welcome everybody. Like Liz said, my name is Nick Miller. I've been with Hydronic Components Incorporated, HCI, for about 10 years now. I'm going to give a brief overview of who HCI is, and then we're going to dive right into six ways and how they work and how we're seeing them applied in the market today. I'm happy to go over any questions at the back end that may come up throughout. So HCI, we strive to be a premier hydronic provider for kits for coils in the industry. We try to customize our package to meet the customer's needs as opposed to providing just an A, B, or C option like some of our competitors out there. Some of the feathers in our cap that we have to our name, we're the global provider for PICVs for Johnson Controls. We're the North American provider for Belimo balancing kits, global provider for IMI six-ways, and North American provider for Oventrop hoses. We are owned by an Italian manufacturer and forgery out of northern Italy, Fratelli Patinaroli. They've been around for 80 plus years, and they're going on their third generation of interfamily ownership currently. And then our sister company, HCI sister company here in the state, is Jomar Valve. So we're backed by a valve distributor here in the US as well. All right, six-way control valves. So what I want to talk to everybody about today is the evolution of the six-way control valve, why it came to be, why are we seeing these in the marketplace today, how do they work, some features and benefits that are good to look for on six-ways, whether it's from us or from a competitor, some different kit designs that you're going to see in the marketplace for six-ways, and then finally finish up with some test and balancing ideas and troubleshooting ideas that it's good to have in your mind when you're dealing with six-ways on the job site. So first and foremost, before we talk about what a six-way is, we need to understand the type of system that these are being used for. So I'm sure most people are familiar with what a four-pipe system is, but just to review, it's two completely independent heating and cooling systems within the building. So this four-pipe system traditionally requires two independent coils, one for heating and one for cooling. And these coils are going to be in the airstream. So what you're seeing in that top picture there is a traditional fan coil unit. Now these type of systems, these four-pipe systems, were great when we were able to put the coils in the airstream, feeding a large zone, a large area with multiple diffusers, maybe a handful of rooms or a couple of classrooms, things like that. With the advent and introduction of chilled beams, which are what we like to call point of use coils, they effectively take the place of the diffusers. It is not economically viable to run these four-pipe systems to every single chilled beam throughout the building. So the goal was to come up with a better solution out there. Some of the other types of applications on top of the chilled beams would be a radiant panel. It could be the radiant fins, or even a traditional fan coil unit, utilizing a single coil as opposed to two coils for your four-pipe chilled beam. So when chilled beams first came on the market, the piping idea was to take that four-pipe system with the two coils in the airstream and put those coils at every single chilled beam, at every single diffuser, more or less. And it was expensive and cumbersome. And when you think about number of coils we're adding to a building, if a single fan coil was feeding 10 diffusers, and we had two coils in that fan coil, we now have two coils at every single diffuser. It can compound the amount of piping and the amount of coils needed pretty drastically. The advantage of a chilled beam and why they're becoming popular is because by moving the location of where we're heating and cooling the air out of the airstream and to the point of use, we're able to get away with a much smaller amount of air circulating through the building. And when you look at the cross-sectional area needed to move X number of BTUs of energy in water versus in air, the piping requirement and space savings is pretty drastic. So chilled beams are a huge advantage when it comes to reducing the overall height of a building by decreasing the size of a plenum. So the savings is there in terms of overall building footprint and overall building savings, but we complicated the necessary piping in order to make this work. So what the engineers tried to do was come up with a solution that was a little bit cleaner, a little bit simplified on how to get the bang for your buck by using chilled beams, but not going overboard with the amount of piping needed to coordinate. So the fix that people came up with was to take this four-pipe system and tie it into a two-pipe coil. And this was done by using 4 two-way control valves, 2 on the heating side, 2 on the cooling side. When the heating side was open, the cooling side would be closed, and you'd have hot water circulating through your fan coil. Vice versa, you could have your heating closed, your cold water open, and you would be getting cold water going to either your fan coil or your chilled beam zone. Now the solution works, but it has 4 control valves, means 4 points of communication back to your building management system, 4 points of failure. On top of that, when it comes to sizing and designing, 2 of these control valves, typically the ones on the supply side, are going to be just on-off without any pressure drop consideration, no CV calculations, whereas the 2 control valves on the return side are often going to be designed to be modulating control with the CV calculations associated with it. So from a scheduling and coordination standpoint, it can be very difficult to make sure everything goes off without a hitch when using this type of design. So that brings us to a 6-way control valve. And as you can see, the 6-way control valve has gone from having four control valves, 4 2-way control valves on every single supply and return from the risers to a single self-sustaining unit with a single actuator. Now, a 6-way control valve can do either modulating or simple changeover between heating and cooling. There's some flexibility when it comes to install, and we'll look at that a little bit more later. And the CVs can be selected on 2 of those 4 ports to provide that quasi-modulating control that we would be looking for if we were trying to do modulating control for this zone. So all a 6-way is really just a better mousetrap for taking a 4-pipe system and tying it into a 2-pipe zone. And we can look at how it works a little bit more detail here. So a 6-way control valve is just 2 3-way control valves stacked on top of each other. Both of them are L-ported, and both of them operate with one another at the same time. So as you can see, starting from position degree 0, you would have your cold water flowing in from the left-hand side, going through the top of the 2 balls, flowing to your zone. You've got cold water flowing to your zone. It comes back and flows through the bottom of the 2 ball valves and back out to the cold water return. As the 6-way begins to rotate from the 0 degree towards the 45 degree, we actually are able to get modulating control on these 6-ways. So there's only typically about between 10 and 30, between 20 and 30 degrees of rangeability, depending on the manufacturer when it comes to modulating control. So the number of steps, number of increments when it comes to doing this modulating is not as good as you potentially see with a traditional 2-way control valve that would be sized for the designed pressure drop. But we have some ways to address that. We'll look at moving forward. But you have this modulating control going from the effectively 0 degrees down to about 30-degree rotation, at which point you're going to hit a dead band where you have full isolation for both heating and cooling. And then as the 6-way rotates the remaining 30 degrees, you are going to be modulating up on your heating control. Another way to look at this is just cold water flows in through port 1, out through port 2 to your zone, back through port 3, and then back to your mains on port 4. And then when you rotate that stem 90 degrees, you now have ports 5 and 6 interacting with ports 2 and 3. So again, we aren't reinventing the wheel here. There's not a whole lot of new technology. It's just a better mousetrap when it comes to providing a compact solution for a problem that has come to light recently in the market with this use of chilled beams. When it comes to the size range for 6-ways on the market today, these are designed primarily for low flow applications. Most manufacturers out there only offer 1/2 and 3/4 inch, with a few out there making a 1-inch solution as well. Similar with the CV range and the max flow, a lot of manufacturers typically max out around a 4.5 CV, which correlates roughly to a 7 to 7.5 GPM flow, with a few manufacturers going above that. But for the most part, we're designing these for a single room. So a single kill beam would be feeding a single classroom or a single office space or a single office conference room, stuff like that, as opposed to trying to zone together very large spaces as you may have done with fan coils or VAVs. And again, it's tied to getting independent temperature control for each room and doing that as efficiently as possible. So paring down the size of these zones makes sense when it comes to using 6-way control valves, hence the typical size restrictions. And towards the end here, we'll look at some solutions for higher flow applications, because a very large conference room or some other larger spaces may require a unique approach to tying these 2-pipe zone into a 4-pipe system. And then connection types on the market today, there's 2 main options, one being fixed FMPT ports on all 6 ports. The other is a union type of fitting on all 6 ports. It's it's more of a preference thing when it comes to one versus the other. One thing to keep in mind is the six-way control valve is first and foremost a control valve. So when we think about traditional control valves in a two-pipe system, we like to have unions bracketing that in the event that it does need to get replaced or field serviced for some reason, because it is the component that's probably moving the most out of any traditional coil kit. So looking at some features and benefits of different six-ways in the market. Every six-way manufacturer has some way of changing or providing different CV values for the heating and the cooling side. So when we think about a typical space, and when it comes to the delta T we can get between chilled water and hot water, the delta T is substantially less on the chilled water, meaning the GPM needs to be higher. And this ties back into the six-way. If we're going to have higher flow through the cold water side of it and lower flow through the hot water side of it, we want to be able to address this within the valve itself, at least to some degree. And this is tied primarily into modulating control. If we are going to try to treat the six-way as a modulating control valve to throttle the flow for both heating and cooling, we want to specify and provide a CV for both heating and cooling respectively that is sized for that. You know, the rule of thumb, 10 feet of head pressure drop or 4 psi pressure drop that controls contractors are going to specify. So everybody out there has the ability to do this, whether it's built into the body inherently to the design, or it's some sort of insert ring or insert disc. There is this feature out there. Important to note from a test and balancing standpoint that the valve should have a tag indicating if the CV rings are installed and which ones are installed in which locations. This is going to come back. We'll talk about a little bit more when it comes to troubleshooting and understanding where pressure drops are located and what readings we're getting, and making sure it all makes sense. Another feature that we need to look for in a six-way, and this is kind of hit or miss. Some manufacturers incorporate something like this, some do not. It's the thermal expansion passage. When you go from full cooling mode, so we've got cold water flowing through your chilled beam zone, to full isolation, and you don't have any type of thermal expansion passage, then the cold water is trapped up in the plenum in this piping. Hot air naturally rises, your water is going to slowly warm, and with no place for this expansion to take place, it's going to increase the pressure and potentially burst the pipe. So what HCI and some other manufacturers have incorporated is this little safety feature where we just shave off a portion of one of the two ball valves that allow the fluid to always be in contact with the expansion tank in the mechanical room. So any pressure changes due to thermal expansion or contraction are always going to be in contact with the expansion tank in the mechanical room. At this point, it's a good time to also talk about the system a little bit with regards to things that need to be considered from a system design standpoint to make sure that you aren't contaminating the cold water with the hot water or vice versa, because these two systems are going to be mixing with one another in the sense that cold water that gets trapped in a zone going from cooling to heating is now going to get pushed out and transferred into your hot water loop. So things to keep in mind: the chemical treatment needs to be the same for both sides of the system. The overall system pressure needs to be relatively close to one another, and stuff like glycol, if it's going to be involved in one system, needs to be in both. So pretty much the chemical and pressure requirements need to be common for both the heating and the cooling systems if we are tying into six-ways and two-pipe zones. As we mentioned earlier, there are these union body designs out there. They can be just straight unions with fittings that go to FMPT to allow service and troubleshooting in the field, or you can tie in flex hoses directly to all of these ports. So we've seen some jobs out in the field that always remind me of the old screensaver from the 90s, the pipe screensaver, where we're trying to tie these 6 different connections into a very small space. We'll look at some other solutions on how to do this efficiently a little bit later on, but one option is definitely to include flex hoses and simply to mount the 6-way up in the plenum on a piece of unistrut and make up any of these additional offsets that could give you headaches if you're trying to hard pipe it with flex hoses. And last component to talk about when it comes to the 6-way assembly would be your actuator. And there's, again, a handful of manufacturers out there that produce both 6-ways and actuators. The things to look for: 24 volts is going to be common for these. These are all going to be low voltage type of controls. There really is no fail-safe solution for 6-ways because the safe position would either be full heating or full cooling. So 99 times out of 100, you're going to see fail and safe actuators. And then controls, it's either 0 to 10 volts modulating or it's 3-point floating. And the 3-point floating is more or less what we consider on-off because you're going to run the cycle time for 30 seconds until it's fully closed and another 30 seconds to open up on the heating side. So it is floating in some sense because we have these 3 points that we need to hit: full heating, full cooling, and full isolation. But we're really just effectively doing on-off with all those points. Last thing to look for, and it can make your life easier and anybody else that's troubleshooting down the road, is a declutchable actuator. Allows you to manually flip between heating and cooling in the field if we are test and balancing, troubleshooting, or filling and purging the system from an install standpoint. Having someone that can go out there and manually adjust the position of these actuators to make sure water is going to all the right places at the right time, especially if the actuator hasn't been hooked up yet entirely, can be very beneficial. So a basic layout for something you might see in a school is having your 4-pipe mains in the hallway with 6-way control valves placed as close to those mains as possible. And then you have your dual temperature piping going from your 6-way to each individual zone, each set of chilled beams. Things to take note of here, and what is common with almost all of the piping layouts you're going to see, is that the run-out piping to the 6-way and the piping coming off of the 6-way are parallel to one another. They're all going in the same orientation. So we need to address that with the fact that the 6-way has your supply and return taps perpendicular to your zone taps. So when it comes to a piping design and the install, something to consider is we need to add some other sort of solution. And then another thing to make note of, the chilled beam, as you can see here in the top of the photo up in the stairway, this is just a 2-pipe solution. But in the event that zone needed both heating and cooling, it may make sense to provide the occasional 4-pipe chilled beam and just run your 4 pipes to if the chilled beam is if it's 1 chilled beam per zone, or it's a kind of an offshoot from the traditional setup that you're seeing. There's nothing wrong with mixing and matching 2-pipe chilled beams and 4-pipe chilled beams, and using 6-way kits and then traditional 2-way piping kits in a layout. So it's an option that can be incorporated. Next up, we're looking at what we would call a traditional detail. And you'll see a lot of similarities between a 6-way piping detail and a 2-way piping or 2-way or 3-way piping detail that you may see for a VAV or a fan coil. First thing on the supply side, we want some sort of strainer, isolation, and a PT tap. That's going to feed into the 6-way control valve. The 6-way control valve is going to feed to either a single chilled beam or a zone, and we'll talk about the piping that happens down in the dual temperature zone a little bit later. But if we go back to the 6-way and look at the return leg coming back to your chilled and hot water respectively, you have some sort of balancing valve, some sort of isolation valve, and they're showing an additional air vent here. So the components required are pretty typical. And if we look at what that looks like in a more of a sketch type view as opposed to a line drawing, we have supply strainers on the coming into the valve, automatic balancing valves on the return, and then piping in your dual temp zone. Again, we'll touch back on this a little bit later on. So from here, for the next few slides, I want to look at some different six-way assemblies that incorporate different types of balancing valves and the pros and cons of those. Because again, the the six-way is just going to either provide on-off flow control or modulating flow control for heating and cooling. We need to bracket that with some additional components in order to make sure that we're getting the performance we want. So it is possible to omit all balance valves entirely and rely purely on the CV discs or the CV preset CV values for the six-way. Not the most recommended solution, but it will provide the lowest upfront cost. Times when this can be applicable and can be a successful design is if you're doing reverse return piping on all of the mains. So every single six-way is going to see relatively equal pressure drops to its neighbors and the rest of the building. In that sense, you can get away with just using the CV discs. But underflow and overflow, it's still going to be likely if we're not designing the reverse return piping perfectly and trying to rectify any flow issues down the road without some sort of type of balancing valve is going to be very, very difficult. So quick and dirty, what we call poor man's balancing, is doable with these CV discs, but it's definitely not the recommended way to do it. And as you'll see for the rest of these kit designs that we're going to be looking at, this is the solution that we're seeing, both that we fab up in our facility and that we're seeing prefabbed at contractors throughout the country, where they're incorporating some 90 degrees, some nipples, and trying to put together this prefabbed solution that's easy to just kind of lift and install up in the plenum. So next up, manual balancing valve. It offers a little bit better flow control because we can actually go through and proportionally balance every single zone to meet the design flow. And troubleshooting is possible by going back and remeasuring and re-verifying flow. But again, unless we're doing reverse return piping and we're incorporating, if we're trying to tie in manual balancing valves with variable frequency drive system, a variable flow hydronic system, you're going to have issues with underflow and overflow. And that's just inherent to having a static balancing valve trying to interact with a dynamic pumping system. So there again, our applications out there for this, but I think for the most part, especially out west here, we're seeing the next solution kind of becoming the most common, most prevalent design out there. And that is incorporating automatic balancing valves with the six-way control valve. Pros are we're going to provide the GPM that the engineer specified up front, and the automatic balance valves are going to compensate for any pressure fluctuations of other things in the system opening and closing to maintain the constant GPM that you need. From a commissioning standpoint, all you need to do is identify the index circuit for both the heating and cooling run. Most likely it's going to be the same six-way for both heating and cooling. If the differential pressure across both the automatic control valves is within the operating range specified by the manufacturer, that operating range is usually 2 to 50 psi, then not only is that index circuit working correctly, but the rest of the system is also balanced as well. So it's a lot easier to go through and verify performance of a automatic balancing valve paired with a six-way than some of the other solutions we've seen so far. The only real detriment to this type of solution is you can only really get on-off control when it comes to the six-way performance. That's because as the six-way begins to close off, the automatic balancing valve is going to try to counteract that. It sees a drop in differential pressure, so it's going to open up the spring and piston cartridge inside of the valve to try to maintain flow. So it's definitely a drawback, but in a lot of these low flow applications, all that might be specified is on-off control for the chilled beam zones, because again, the GPMs we're flowing through here are very, very low, and we don't see modulating specified nearly as much. So, and a lot of times, this is the kit that might solve all the problems for tying that 4-pipe system into a 2-pipe chill beam zone or a 2-pipe fan coil, whatever it might be. But I want to look at some other things that you might see in the marketplace, if not today, then coming down the pike as kits out there that we're starting to see. First one is going to be tying PICVs into the 6-way kit. The 6-way itself is going to purely act as the on-off changeover device, while the PICVs are going to be providing all of the modulating flow control. By using PICVs, we're getting that modulating flow control. We're getting the design GPM. It's going to react to differential pressures, and balancing in the field is relatively easy. Or sorry, rebalancing in the field is relatively easy, as all PICVs have some way to adjust the max flow in the field. The issue with having the 2 PICVs on the branch side or the main side of the 6-way is that, again, you're providing 2 valves, so it's 2 additional actuators, and you're adding more complication to the building management control. One way of helping to simplify that is to actually provide the pressure independent control valve on the dual temperature zone portion of the 6-way assembly. Advantage is all the same as before. You're getting that modulating control that you were looking for. Balancing is relatively easy. You can field adjust max flow to a degree. The con really is that the actuator for the PICV has to be what we call a smart actuator, and has to talk back to our 6-way control valve. The PICV actuator needs to know if hot water or cold water is flowing through it, because a lot of times those are going to be different max GPMs. So if you have 8 GPM on your cooling side and 2 GPM on your heating, the PICV needs to know what its current quote unquote max GPM is for the application. And if that difference between GPMs is very drastic, then you're going to have a very poor control on the lower flow, because if the PICV is designed to handle that 8 GPM solution, but also has to be able to modulate down to that 0 to 2 GPM solution for heating, the amount of modulation is going to be very, very limited. And last but not least, we're also seeing 6-ways on the market with tied-in flow sensors. The really only issue we're seeing with these in the marketplace today is cost. The ultrasonic flow sensors are still very expensive compared to some of the other solutions. Even other solutions utilizing 2 PICVs and quote unquote dumb actuators can be more cost effective than this type of solution. But again, you have a flow sensor that's talking back to your smart actuator on the 6-way in this case, telling it what GPM it's actually seeing, and the 6-way actuator knows, is it heating or is it cooling? Do I need to modulate up or down a little bit? And this solution can remove any additional balancing valves. You're still going to need your trim kit in terms of strainers and isolation valves, and somehow making up those 90s. But this can remove any additional balancing valves needed for the system. And all balancing would be done electronically through reading the GPMs in your flow sensor. So what we looked at so far was your more or less worst case to best case scenario when it comes to designing a kit around a 6-way. And that was all for the low flow zones, the single rooms, the stuff like that. Now I want to look at some high flow changeover station solutions. First, what we have here is a kit that is just mimicking what we're doing with the 6-way, where we're breaking the 6-way apart and providing 2 3-way valves and all the trim kit associated with it. But if you add up all of the actuators, you will notice that we are back to that 4 actuator scenario. So we aren't really saving any control logic or complexity when it comes to the system design. So what I recommend, and what I think we're seeing more and more in the market, is use the 6-ways where applicable, but don't be afraid to step back from that and go back to the quote unquote fixed solution we looked at in the very beginning, using 4 separate control valves. If it doesn't make sense to try to fit the round peg of a 6-way design into the square hole of a large flow application, let's go with a tried and true solution, which is just 2 on-off control valves, 2 control valves that either do modulating or are a PICV, and then they're just specifying is hot or cold water going to the zone at the time. So up until now, everything we talked about was the components between the mains, the hot and cold main, and the 6-way itself. I want to take a quick second to mention the balancing and valving required after the 6-way control valve, because you do have all of these components that are getting zoned together. I'm sorry, all of these field beams that are getting zoned together somehow. The first is with direct return piping. If direct return piping is used downstream of this 6-way, then incorporating some sort of balance valve is recommended on every single field beam. You can go through and balance these to the higher of the 2 GPMs and just use proportional balancing to get the relative GPM for each field beam to be the correct ratio when it comes to comparing it to its neighbor. And then when you switch from cooling to heating or high flow to low flow, whatever it might be, the system, the downstream of the 6-way is still going to stay balanced. The other solution is, again, reverse return piping. You can use reverse return piping for the dual temperature zone. It is adding more piping, which is one of the things we're trying to get away from. So it's a cost analysis that needs to be done, whether it makes more sense to do the reverse return piping or to include manual balancing valves. For the most part, we're seeing manual balancing valves still being used in the market as of today. And then last thing, just to kind of reiterate and touch on a little more detail, when it comes to balancing and commissioning and testing and verifying performance of a 6-way kit, really is nothing different than what you guys have been doing with manual balancing valves, automatic balancing valves, pressure and control valves, even energy valves that you've seen to date in traditional 2-way and 3-way kits. We're just kind of making the 6-way, making the control valve a little bit more complex. So first and foremost, we're going to want to measure the differential pressure across the balancing valve if a balancing valve is present. If it meets either the design differential pressure that the manual balancing valve is provided with in terms of the tag or the chart or the wheel, whatever it might be, you're balanced. And then automatic and PICVs is just going to be a pass-fail test to make sure that the differential pressure is within the operating range of these valves. Secondary tests are always available as well with pressure drop through your 6-way. I mentioned earlier that the 6-ways all have a CV disc designed to be inserted or designed into the body that goes in the outlet bottom port of both the heating and cooling. So if you're able to measure the differential pressure on the return line coming back from your dual temp zone to your return heating or cooling, and with the knowledge of where that CV is, you're able to double check flows in this sense as well. And then lastly, delta T across the coil or discharge temp are always a viable way of troubleshooting the system. And I think with that, that is what I wanted to go over and talk to you guys about today. At this point, I'd like to open it up for any questions or comments that anyone may have out there.
Okay. So I don't see that we have too many questions. It looks like you did a good job today of explaining it all. We appreciate that. Just a reminder to everybody, in case you do have some questions, answer them through the question panel, but a copy of the PDF slides from this presentation will be sent electronically to all of you who are registered for today's Tech Talk. The Tech Talk has also been recorded today and will be available on our website under the resource section. There is a new password to all Tech Talks and it will be emailed to all members after this presentation. And just a reminder that the last of our fall webinars is coming up on December 9th, and it's commissioning contracts and hiring a CXP. And Nick, it looks like we did get a couple of questions in. The first one is, how many plumbing issues do you see? Whoops. How many plumbing issues do you see getting the six-way port wrong?
With terms of as far as piping the hot water on the cold water side, or vice versa, or incorporating
Yeah.
the.
So, i.e., I'm sorry, this panel does not want to open all the way.
So it has been known to happen. The one thing that I don't know if it was intentional or if we all six-way manufacturers out there have pretty much standardized that when the two bottom T ports or center ports are facing to you, that cooling supply is going to be your top left, cooling return is going to be your bottom left, heating supply is going to be top right, heating return is going to be your bottom right. And I don't actually have an answer for why that's the case, but it is kind of what has happened in the industry, that we've all standardized around this similar design. So there shouldn't be a whole lot of with that understanding, there shouldn't be a whole lot of concern about incorrect piping. If there's ever any questions, all manufacturers out there have detailed IONMs and spec sheets available for piping and stuff like that.
So the next question, what is the cost installed differential between two separate valves versus one six-way valve?
That is an excellent question, and it ties in a lot with the peripheries and stuff that's being involved. If we take all of the kit components out and we're just looking at 4 individual two-way control valves as opposed to one six-way control valve, the cost is substantially less of a six-way control valve. Unfortunately, I don't have a percentage in front of me. If I had to ballpark it, 15 to 20% less for the six-way assembly. Yep. And that's that would be for both the actuator and the six-way itself. So there's a cost savings there, and that can get compounded into the number of additional components needed to make the kits function properly. We're minimizing additional unions potentially on using a six-way control valve in lieu of two-way type setups.
Perfect. Okay, the last question I see here. Are system pressure and chemical treatment the only concerns when changing the system between heating and cooling?
Yeah, and then the media as well, just if glycol is involved. The system as a whole it's effectively one big closed loop system that's just moving water from heating to cooling and vice versa occasionally. So as long as both systems are pressurized equally, and what's going to happen even if they aren't perfectly pressurized equally, it's going to find that equilibrium after the fact. But maintaining good chemical treatment on both sides and then having them pressurized equally are the main points of concern when trying to tie this 4-pipe to 2-pipe solution.
Perfect. Well, thank you for your time today, Nick. We really appreciate you spending time to educate us. And I want to thank all of you for joining
Absolutely.
today. And we look forward to hearing from you after the first of the year, as we don't have a Tech Talk in December, but we will be back on track in January. So thank you, everyone, and have a great holiday season.
Thank you, Sherry.
Thank you.
Bye-bye.